If you're a student or beginner trying to understand IT, information systems, or programming without the confusing jargon, welcome to LD Tech Lab. Make sure to subscribe, and let's break this topic down step by step.
Today, we are moving from Java Basics to Java Intermediate. If you already know variables, loops, if else, but you still feel confused when programs get longer, this lesson is for you. Java Intermediate is not about writing more code. It is about writing better and cleaner code. Many beginners put all their code inside the main method. While this works for small programs, it quickly becomes messy. When errors appear, they are harder to find, and when changes are needed, more mistakes happen. Java Intermediate helps solve this problem by introducing better organization. A method is a group of instructions that performs one specific task. When you place code inside a method, Java does not run it automatically. The method only runs when it is called. This allows you to reuse the same logic without writing it again. When we create a method that prints a greeting, Java stores that set of instructions under a name. When the method is called, Java jumps to that code, executes it, and then returns to where it was called. This avoids repeating the same print statement many times. Calling a method means telling Java to execute the instructions inside it. When Java reads the method name followed by parentheses, it knows exactly which block of code to run. This makes programs shorter and easier to read. Parameters allow a method to receive data. When a method has parameters, Java temporarily stores the values passed through it. This allows one method to produce different results depending on the input. This makes methods more flexible and useful. When a name is passed through a greeting method, Java replaces the parameter with the value provided. The method then uses that value inside its instructions. This allows the same method to greet different people without changing the code. Method overloading allows multiple methods to share the same name but perform slightly different tasks. Java determines which method to use by checking the number or type of values passed. This keeps method names simple and code easier to understand. A class is a blueprint that describes what an object should have or do. An object is the real instance created from that blueprint. When an object is created, Java allocates memory and allows the program to interact with it. When a student object is created, Java creates a real entity in memory that follows the class definition. Assigning values to the object means storing data inside that memory space. This is how Java represents real-world entities. Encapsulation means protecting data from direct access. When variables are private, they cannot be changed freely from outside the class. This ensures data remains valid and prevents accidental errors. When a method is used to set a value, Java checks the input before storing it. This gives the programmer control over how data is modified. Encapsulation improves safety and reliability. Constructors are special methods that run automatically when an object is created. Their purpose is to set up the object correctly from the start. This prevents incomplete or incorrect objects. When a constructor receives values, Java immediately assigns them to the object's variables. This means the object is ready to use as soon as it exists. The this keyword refers to the current object. It helps Java distinguish between a class variable and a method parameter with the same name. This avoids confusion and improves clarity. Static variables belong to the class and are shared by all objects. Non-static variables belong to individual objects. Understanding this difference helps avoid logical errors in programs. Arrays store multiple values but have a fixed size. Array lists can grow or shrink as needed. Knowing when to use each helps manage data effectively. Many learners still rely too much on the main method, misuse static keywords, or avoid encapsulation. These mistakes are part of learning and help reinforce why structure is important. For this activity, you will build a simple student information system using Java. This mini-project is designed to help you apply what you have learned in Java Intermediate, not just understand it. You are not expected to build a large system. What matters is that your program uses the correct concepts in a clear and organized way. Your task is to create a student class. This class will represent a real student. Inside this class, you must declare private variables for the student's name and age. These variables must be private to show that you understand encapsulation and data protection. You should not allow direct access to these values from outside the class. Next, you must create a constructor for the student class. The constructor should accept the student's name and age as parameters. When the object is created, these values must be assigned immediately. This ensures that every student object starts with valid data. This step is important because it demonstrates proper object initialization. After that, you need to create a method that displays the student's information. This method should print the name and age in a readable format. When this method is called, Java should display the stored data of the object. This shows that you understand how methods work and how objects perform actions. Once your student class is complete, create a separate class that contains the main method. Inside the main method, you must create at least one student object using the constructor. Provide actual values for the name and age. Then, call the method that displays the student's information. When your program runs, the output should clearly show the student details. As you write your code, remember that this project is not about being clever or using shortcuts. It is about writing clean, readable, and organized Java code. Proper indentation, clear naming, and correct structure matter. If someone else reads your code, they should be able to understand it easily. After completing the project, take a screenshot of your code and the program output. Make sure both are visible. Then, submit or post your output as instructed by your teacher. If this is part of an online activity, you are required to share your answer in the comments or submission area. This is not optional. Sharing your output is part of the learning process. This mini project proves that you can combine classes, constructors, methods, and encapsulation in one working program. If your code runs and follows the instructions, you are already thinking like an intermediate Java programmer. Remember, good Java code is not complex. It is clear, structured, and easy to maintain. Complete the task, run your program, and share your result. Java Intermediate focuses on thinking clearly and organizing logic. Good programmers prioritize readability and structure over speed. Clean code is easier to maintain and improve. Java Basics teach you how to write code. Java Intermediate teaches you how to build programs that make sense. Master this level, and advanced programming will feel much easier. Follow this page for more Java lessons and real coding examples.
If this video helped you understand the topic better, please like, subscribe to LD Tech Lab, and comment below what you want to learn next. Your questions help shape future lessons.